Okay. Oh, welcome everyone. I think I'll just wait some few minutes for everyone to join. All right, I can see any great my people. Okay. Yeah, I can see Andrew, Bright, Captain Michael. Yeah, mm, I can see Kabi, Montserrat, Awakal, Tolulose, Toluwani, Basiru. Yeah, welcome everyone. Hope you guys can hear me clearly. So if confirm that you can hear me.
Yes, we can hear you
Oh,
loud and clear.
all right, that's fine. All right, welcome to day two of the live coding session for stage E. And the stage is about time series data. And in our last class, we told us that we're actually going to be looking at a real project and we're going to be looking at the project the for all the classes we are going to have. And we went through it in our last class with some methods before we ran out of time. So today we're going to continue from where we stopped. I think I will throw more light on or recap on what we did in our last class before moving forward. Yeah, so unlike the last time, I have slides for today, so we'll just quickly go through it and have more understanding about all the kinds of terminology, so that when you see them probably in the project itself, you will not be confused. You have an idea what it's all about. So let me just take my there. Okay. I want to believe everyone can see my screen now. All right. All right. So we are just going to, like I said, go through some terminology and get an understanding of something. All right. So yeah, we'll start with what is a time series, right? Yeah, let's start with the basics. What's a time series? So a time series is simply a sequence of data points collected or recorded at regular time intervals, right? So you're saving your data on a daily basis. You are making entries on a daily basis. It's simply a sequence of data points collected or recorded regularly at time intervals. So for example, think of the daily closing prices of a stock, which is the case we are looking at in our project, or the monthly sales figure of a stock. Each data point is associated with a specific time. Right? So time series data helps us analyze patterns over time, which is crucial for making predictions and informed decisions. We have components of time series. So let's let's break down the components of the time series. First, we have the trend, which is the long-term movement in the data. That's a trend. I didn't have time to put images like like a sinusoid. That most times, let me not say most times, you can picture a sinusoid that way, right? At the trend of maybe your time series data. It can be upward, downward, or even flat. You've all heard of USDT, you know that it's a stable coin. So if you look at its charts, it doesn't really have that up and high like USDT would have, right? So it's flat. Then there is seasonality. which refers to regular repeating patterns in the data, like higher sales during holidays. So it's seasonal. Let's say December, obviously, you know that if you are the type of person that sells rice, right? I'm using rice specifically, right? And you usually make entries on how much rice you sell, let's say for the whole year, or let's say on a yearly basis. If you plot that data, that means that there is going to be a spike for rice sales in December because it's Christmas is festival period, right? And it's more for rice that people will take. So that's seasonality in the data. So it has a pattern. Every December there must always be a spike. So let's say if you want to invest in rice now, you probably need to maybe, oh no, buy it when it's cheap. And when it gets December, you can then sell it at maybe a high price if the price is going to increase by then. But yeah, that's what seasonality is all about. Okay. Then lastly, we have noise, which is the random variation that we can't predict or explain. It's just there. It's not predictable. Neither can we explain it, right? So these are the few components of a time series, and yeah, understanding the components helps us analyze the data more effectively. Okay. Now, what's the importance of time series analysis? Why is time series analysis important? One, it allows us to focus, sorry, it allows us to forecast future values based on past data, which is valuable for planning and decision making. So we can make use of the past data to help the future, especially when there is a pattern to, for instance, businesses use it to predict sales, manage inventory, and plan marketing campaigns. Then in the healthcare industry, it helps in monitoring patient health and predicting disease outbreak. Overall, it's a powerful tool for various industries to make data-driven decisions. So these are few of the importance of time series analysis. Now let's look at the use cases in different industries. Let's look at some real-world applications of time series analysis. In the finance industry, for instance, time series analysis is used to analyze and predict stock prices. Okay, that's how useful it is in the finance industry. In the retail industry, the retail is the business, the sales, and the likes, right? It helps forecast sales and manage inventory. Then in the healthcare, it monitors patient vitals and predicts disease outbreak. And in meteorology, it makes studies. I mean, what do you think is behind yeah, what do you think is behind weather forecast and the rest of them? Right. So most times it know that okay, at this time of the year, it's usually raining, it's usually sunny on the left hand. I mean, there are other factors, right? There are other factors to it. But yeah, it is obviously so sorry about that. Okay, can you guys still hear me?
Yes, we can. We can hear you.
Yeah, sorry about that. I just got um okay. So I was trying to explain the different case scenario of time based analysis that we are talking about. Okay, so in finance, it's to predict stock market. In the retail, it's used to forecast sales and manage inventory. In the healthcare, monitor patients' vitals and predict disease outbreaks. And in meteorology, it's used for weather prediction and climate studies. So these few examples show how versatile and impactful time series analysis can be. So now, speaking of the data itself, how does it look, right? For what data can you say is a time series? I mean, you won't just because your data has it in it, you just say I mean, at some point you will say it's a timely data, right? But then again, for you to be able to forecast very well in terms of time series, the data needs to be like you need to have a lot of data points so that your predictions or your model can learn better, right? Yeah. So we have the data itself. So time series data consists of observations recorded at specific times. Each observation can be anything from number. So we have two main types. Unit, I mean, we also have it in terms of visualization, like univariate plot and multivariate plot. A single variable recorded over time, like daily temperature. So what you just have is just single variable you're looking at that point. The multivariate series involves multiple variables like temperature and humidity. Just like in our project scenario, we have the open, the closing field variable. Now, understanding this data structure is the first step in effective deployment. I'm sorry again. Well, okay. Sorry about that once again. So we have the visualization where you visualize data to understand or have a pictorial view of what it looks like. So the most common way to plot time series data is using a line plot, right? For example, plotting daily stock prices over a year can reveal trends and seasonal patterns. So in Python, we are all familiar with matplotlib and seaborn, and we have other ones, ggplot, plotly, and yeah, the likes of them. So visual plot make it easier to identify and analyze different components of the time series. Time frame. Okay, identifying trends. So identifying trend in time series data is crucial. You can start by visually inspecting the plot to see the overall direction of the data, right? For a most precise approach, we use statistical methods like moving averages, which smooth out short-term fluctuations and highlight longer-term trends. We're going to see that in our project. So for example, calculating a 7-day moving average of daily sales can help us see the trend more clearly. Reporting trends helps us make better predictions and decisions. So we have the seasonal pattern. I talked about it some slides back. So seasonal patterns are regular repeating cycles in the data. For instance, a retailer might see higher sales every holiday. I explained this. So we use method like seasonal composition of time series to break down the data into trends, seasonal and residual components, and we're going to see this in our project too. So by understanding these seasonal patterns, businesses can plan better for peak times and manage resources efficiently. Uh, this is just a scenario verbally, right? So imagine we have a monthly sales data for a retail store over several years. First, we plot the data to observe any trend and seasonality. Next, we apply seasonal decomposition to separate the trend, seasonal and noise components. So this analysis can help us to make informed decision about inventory and marketing strategies during peak season. So seeing these concepts in action makes it easier to understand and apply. All right, this end of the slide. So to recap, we look at the importance of time series analysis, and we also talked about how to visualize and identify some trends and yeah, I mean, this would be a basic for what we saw in our last class. I'm sorry I didn't have the slide ready by then, but yeah, these are the basic things you need to have in mind so that it will be easier for you to comprehend what I'll be showing you in the notebook. Does anyone have any question before we go into the code? Okay, I'll take the silence as a no. I'm going to join my voice right now. Oh, sorry. And you guys see my VS code? And you guys can you see it? Can you all see my notebook or my VS
Yes,
code?
we
Sorry.
can.
All right. I mean, it may take time to go through what we did in our last class, but I'll just quickly go over it. Yeah, we have the video, so you likely just watch the last class to maybe catch up with us. But yeah, we're looking at the time series projects that was actually done during internship like the one you're doing. It was just one of the projects and which I was part of. Okay. So we did exchange rates predictions and in our last class I basically walked up through the objective and some stuff about it and how our model was designed. So yeah, I'll just use it to go through what I've done. Then I'll keep to where we stopped in our last class. So that will cover a lot. Yeah, we did the data collection. We basically just loading our data set, data processing. We visualize. We did some decomposition. Then we take proportionality if the data is stationary or not. So very well, Arima model actually works well with stationary data, while Prophet works with like Prophet can adapt to stationary data, right? So what we did was to check if the exchange is stationary or not. And yeah, somewhere in the code we had to convert some of them to stationary data so that we can use Arima model. So once it's done, when we use it on it, we do some fine tuning and evaluate the model, and then we actually deploy this using Streamlit application. So I said I was going to show us that probably towards the end of the class, but I'll need to check if the Streamlit app is still active. But yeah, this is just a snapshot of our model, how we design the process and everything. Then, yeah, again, what I also said was important about this project, or what I would love for you guys to learn. Probably some of you are aware of it, is just how to make your work plain. So, yeah, to my right are basically all the code and functions that were all imported into this notebook and were used. So, I'm just going to go over it again. Here are the libraries we brought in: NumPy, Pandas, some visualization tools that come model. We have the other polar text to take for stationarity. Then we have our model. Yeah, we have some evaluation metrics to evaluate. We have our RIMA model. So these are the libraries you would on a norm import in your main notebook. So it's actually in a Python script. This is a module called main function. So here we are importing it in, make use of all the functions that are in there. Okay. So yeah, I'm importing these functions which is on our right hand side. The tabs review, we talked about this. It's just going to show five rows of our data sets after loading it in. Then yeah, we talked about the data set in our last class. So I seriously don't want to spend much time on explaining what I did the last time, but yeah, we splitted this column into two, column A and column B. I think I should start my sorry, let me start my panel so that to be from scratch. Okay. Okay, so after getting a preview of our data, we splitted this log column into two, separating the left hand side and the right hand side. So the left hand side are actually the base currency, right? So yeah, this is where it's being okay, this is where it's being done. We call on the function called log split. This is it. It's in charge of splitting it, and I explained this in our last class. So it gets split into the columns A and B. Then we check for this of currency A and currency B. So what this is showing us, it's saying that on our data sets, right on the left hand side, we have seven unique currency. That is the base currency. There are seven of them. While on the right hand side, there are 113 unique currency, right on the right hand side of our exchange. So this is just another brief information about our data sets, and that is being done using this using this function here. The function was designed to present this information. So we have the right up there. Then the next thing we did, yeah, was to plot, visualize data set. So we call on this function plot visual. And all you need to do is just pass in a currency pair, like one of the base currency. Right. So I can change it to, let me see, one of the base currency was let me use Australian dollars, AUD, right? So I can actually change it to AUD. Then the OHLC that I need to take it to false. So I actually removed it because if you remove it, what the function does is if you don't set OHLC to true, it's not going to plot the visual. It's just going to return the first five rows of that currency. Right. So if I set OHLC now to true, it's going to do a going to plot a visualization. So you can use the end to control how many visual it plots for you, how many exchange it plots for you. If I increase it to three, right, it's going to plot three visualization for three different exchange. This is Australian dollar with I don't know what it is, but yeah, this is the plot. This is Australian dollar with Canadian dollar. This is the trend. This is Australian dollar with look like Mexico something, but I'm not sure. Yeah. So yeah, this is just what that function is designed to do, right? We explained this in our last class. The currency selection. I think this is where we stop. Right? Yeah, this is where we stop, and this is where I'll start explaining with more details, right? So just in case you have any question while I'm explaining, you just feel free to ask your question. All right. So this is just like I said, a preview of our data set. Sorry, a visual of the exchange for just Australian dollars and plot play, meaning that you can always zoom in and then you use your cursor to zoom in on some range. And this is a candlestick, and I explained this to you in our last rising that when it opened at a high price, like this one I'm hovering on, it opened at 9.17, but at the end of the day, it closed at 8.89. So at the end of the day, it's reduced. That's why the color is red. Okay. Then the high and low is, it said, that, what that means is, for that whole day, that 16th of August 2007, the highest that price went to was 9.179. Then the lowest it ever went to was 8.805. So that's the interpretation of that particular candlestick. Then for the ones that are green, it's obvious. It's the ones that opened at a low price and closed at a higher price than what it opened at. So for this one I'm hovering on, it opened at 9.02 and closed at 9.06. So a difference of 0.04. So it increased by 0.04. Okay, so that's just it about this plot. Now, the next thing that happened after we just visualized our data was to collect I mean, we want to predict, so we can't just predict everything at once. We need to focus on one. So this is where the selection of the currency we want to predict is being done. So whenever you choose currency A, it's the base currency. It's the currency on the left hand side, right? So this is where you do the selection. If I run this cell, it's just going to ask for what's my currency A, what I want my currency A to be, what I want my base currency to be, and this is the function behind it. So let me run it so you see what it does. So it's asking for an input. So you just need to pass in one of the seven base currency, right? So I can use let's say British pound. So the result it's presenting on the output is it's showing us the possible currency exchange for this British pound, meaning we can have British pound slash BBD, this British pound slash BBD, right? And so on and so forth. So these are the possible exchange that is available for this British pound. If I change it to, if I run it again and let me say I put in, um, let me, which other base currency do we have there? We have euro. So let me put in euro and Japanese yen. So you have USD. Okay. Okay. So let me put in euro. EUR enter. So it's you see it's fewer than the other one. So what this is saying that these are the possible currency exchange. That's possible currency B for euro. So we have euro slash CRC euro and so on and so forth. So these are the possible currency exchange based on our data set that are available. So it is from here now that you can go ahead to do the selection of currency B based on what you've chosen. So you don't end up going and choosing what is not available for another base currency because you agree with me that the output here is low, it's more compared to the one for Egyptian pound. So that's why we did this. So I think I will just have to explain what the function is doing on the right hand side. So what it does is, oh no, this is not it. Okay, yeah. What it does is, we also have a parameter called preview. Actually, it false. So let's see what happens if I take it to true. Let me put in here now. Okay, it's not returning anything. It's okay. Okay, hold on. Let me try something else. Okay. Is it? Okay. So what happens is right now it's returning two items, meaning that I can access the preview by doing something like this, indexing the output. This is the preview, while I can access the data itself using index one because I have actually set yeah preview. So let me just explain the function. So we have a parameter called preview. It falls by default. What happens is pick the data set. It clicks it. So this log split is that when it divides this stuff into A and B. After splitting it, it requests for an input. This is where you pass in whether you want Egyptian pounds or USD. So once it takes it in, it goes ahead to filter our main data set after it must have split A and B and filter it, narrow it down to that currency. So it must be one of the base currency. So once it has filtered it based on this column A, the preview is now then set to that filtering dot head. It's actually the one that I ran was one that was index zero. Okay. Then yeah, now using that same data output, we filter or we get the unique values in column B. So it now then becomes the possible currency B. That's the possible exchange that is associated with USD. So it just returns a unique value, right? Then what we do is just return it to the output. So it's just a statement below the possible currency for whatever currency you pass in. Then it will now then return the unique value, unique exchange that is available for that particular currency. So if preview is set to true, like in this case, it will return two output. One is the preview, which you can access by indexing zero, right? Everything is set to this guy. While the other one, which is the data itself, that is entire data can be accessed using index one, which is actually what we are going to use in the next function. Please, if you have any questions, feel free to ask. And I just hope you are following. All right, so yeah, that's what is happening at this stage. Now we are selecting currency A, the currency we want, the base currency we want to work with. So okay, let me work with the compound, because that's what I've been using so far. I don't want to alter what I've done already. All right. So I'm just going to use index zero here. Now we've selected currency A. Now the next thing we need to select is currency B. We want to select the currency B now. The Egyptian pound is our base currency. Now what do we want to do the Egyptian pounds with? So this is where it's been the, so if I run this now, hold on. Yeah, that's the website now. Well, really, it just okay, okay. So I need to pass in the entire data set. So pardon me, when I ran this, literally saved two two results to this guy. So right now it's holding two results. One is the preview, while one is data itself. So I can't just come in here and make use of it. So I need to specifically make use of the entire data set, which is one like this. Yeah. So what this guy is doing, okay, sorry, this is not really select person, pardon me. What this guy is doing, what this function does is it displays based on your selection the possible currency B with your base currency. It displays the shape of your data. So it's saying Egyptian pound slash this is 4,536 rules, while Egyptian pound with this as an exchange is this shape. So this is just the first shape of the possible currency with Egyptian pound. So what I'm saying in essence is it's giving you the shape of all these guys here. And it's not showing all because there is a parameter that helps you filter it. So if you want to see all of it, you probably need to set that X to a value that is larger. But default is 5. So it returns the shape of the entire data set. So from here, you can choose to maybe work with the one that has higher, larger rows so that your model can work fine, or maybe work with the lower one. But here, it shows you the shape of your data set. So this is the function that is handling that, right? It has an empty list, so it looks through the unique value, all these guys that are highlighted here. Then it just goes into the data and filters it based on this. It gets the shape, you know, and if it's set to pre, returns the shape. And yeah, so that's what that function is doing. And this is where we select the second currency we want to work with, right, out of the menu up there. Okay. So if I run this, again, these stuff are dependent on each other because right now, this is printing the shape, then also it's saving the entire data set to this map. Okay. So whatever I select, if I run this one, I'm going to ask for me to select my currency B. So I can work with the Egyptian pound. Now, what is this function doing? It helps you select the second currency that you are trying to predict from the based on the base currency you selected, and it also returns the entries or the days in which there are missing entries. These are missing entries. It means that on the 11th of April 2001, there was no entry. There are missing values actually. That's just a summary of what I'm trying to say. There are missing values in this data set. So this is just giving you a snapshot of some missing entries. So let me explain what this guy is doing. Um, it is the function behind that, right? So it goes in, it asks for an input. Now, based on that input, it's going to filter currency A, which is this map. Right now, this map is holding everything filtered to British pound. You're going to filter it based on the currency that you pass in. Then it sets the index. It sets the date. There's a date column in that data set. Yeah, it sets it as the index. Okay. So once you set it as index, I mean convert it to an index just in case there's it's not a date data type. Then we have the start date and the end date. By default, it sets to zero outside the function. By default, because you want this stuff to be dynamic, right? So once it's done filtering, it will pick up the start date and end date and set it to the minimum and maximum date of that filtering. So let me just go over it again. So we've selected Egyptian pound as our base currency. And here we selected British pound as our base currency. And here we selected Egyptian pound. So right now it is something like this. This is the exchange we are working with right now. So the whole up to down right now at this level, what we have is that entire data set filtered to just exchange. So for just this exchange, it's going to pick up the minimum date and the maximum date. That's what it's going to assign to that and end date just for this exchange. Then for the missing entries, it turns it picks up that start date and the end date and turns it into a range. Then does a difference. Like it looks for where there are missing value, where there is empty date, and returns that difference to the output. So it's that difference that we are seeing here. So in other words, there are missing values actually. There are some dates that are not entries, right? So if the preview is set to true, yeah, if the preview is set to true, it's just like the other one. It returns to value where you can get a subset, right? But if it's not, it's just going to return the current parameter that it returns A underscore B, which is just the filtered out. I really hope you understand. But again, if you have questions, feel free to ask. Now, seeing that our data has granularity, the granularity of our data is in days. They're actually in days, right? So we decided to downsample it to reduce it to week. That was the approach we used. We decided to downsample it to a weekly frequency. Okay, don't mind the name of the function, but it's actually downsampling it, right? Because it's reducing the granularity from day to week. So yeah, what this guy is doing, this next function is okay. Let me just read this. The data was downsampled to weekly records because of missing any different missing values. That was the approach we used, right? I mean, you can't upsample it because already it's in date unless you want to take it to seconds and probably data does not have the switches. So we can sample it to make amend for this. So yeah, that's what this function is doing. Again, please ignore the fact that it's called upsample. We're actually downsampling it. Okay. So yeah, let me just explain the function. And this is output. These are actually the missing value. Let me run this. Right now, A underscore B is coming from here. So A underscore B right now, I think I should just show you the data preview so that you understand what it told him, so that will not just be floating. So let me set my preview, quantity, okay. That was digital pound. So I can come here and show you the contents of A underscore B so that you will not be on the blind side. So this is it. This is the content. Sorry. You need to index it. Index, oh, indexer. Yeah, this is the contents of our A underscore B. Like I told you, just this exchange and first five rows. Right, so that's what is coming in here. It's reducing this date from daily basis to weekly basis. Okay. Or if you want to see the entire data set, you can just change this to one. This is the entire data set. Okay. So you test the data, we can pull it again. Again, these are actually missing values in those respective columns. Now let me explain how this function works, because all it does is just take in the data frame and just give this result. This is the function we're looking at now. So it gets the hello, can you guys hear me? Can you hear me now? Hello.
Hello, we can hear you. We can hear you.
Yeah, that's fine. Does anyone have any questions before I continue? Is there any question, or we are all understanding what I'm saying?
Okay.
Okay, I'll take it that we are all understanding. All right, so I want to explain this downsampling, what how the function works. So it resamples it to a weekly basis. So if the label is left, meaning it labels the weekly intervals with the left being age, then the close to is left. So this is the interval on the left. Then yeah, when we resample it, obviously it's like you grouping the data into weekly basis. So when you're grouping the data, what do you want to happen to the numbers? Are you summing it up by week? Are you looking at average? So it's actually by mean. We're looking at average. So we sample it to weekly, and we are computing the mean for those numeric columns only for each week interval. Then again, it picks up that date and the end date, like the minimum, and it's already saved here, but everything now is dependent on one data set. Pick it up and then turn it to a weekly frequency, right? Then do the difference. Okay. So yeah, I mean, sorry. Okay. I'll treat this, but it resamples it to weekly, right? It picks up the start data and the end data, the minimum and the maximum week dates, because the frequency is going to be converted to date. And it does the difference. This is actually to look for missing entries, right? So, but then again, we did a forward fill for the close column because that is actually going to be our prediction column. I think it explains here. So yeah, it also prints out the days with no entries because it's of the data leakage. Only the close variable will be used for prediction. Thus, missing value for only the close variable will be handled. I mean, we don't want, this is actually a finance data. We don't want to value alter or make changes like that to it. So we decided just to fill in missing values for the target variable since that's what we are using for prediction, and we leave the rest as it is. Okay, so that's what we did here. We did a forward fill, then we checked for missing value just to show you what the missing value are, and then we return the shape. Yeah, we also return the exchange itself. So this error is actually occurring because right now my A underscore B is holding two results. So I need to use an index to
Just
tell
or
it
integers or
which one to work
slices.
to. I need to change to put this as one to work fine now. So this is the result actually for, yeah, British pound and Egyptian pound. So in the open high low we have 148 making interest. I mean obviously the closing you're not going to see any because we've handled it using a forward fill, and that is actually our target variable. So this is the shape of the data. It has after down sampling it, obviously the shape is going to reduce, and it reduced from 4,536 to 1,065. Yeah. So that's us down sampling our data set to a weekly basis. Right. Now the next step we did plot of feature to check if any dependent variables are present was to visualize the data set, the weekly plots we've just finished downsampling, right? And we also brought out some good statistics that will help us, understand the data very well. So I'm going to be explaining this in the next few minutes, and we call it a day for today. Yeah, because our time is almost up. So we have a function called weekly plot. That is the next function on this list. It's a little bit long, but it does a lot of things. First of all, it plots a visualization. So I think I need to run this again because our data is not USD. We are working with Egyptian pounds. Let me run this. Yes. So this is what we have. You're working with Egyptian pounds slash sorry, British pounds slash Egyptian pounds.
No,
Right now,
you can just talk change. Time to use data. Because just to change data is time
someone
sensitive.
saying something. Who is who is that? Someone is distracting me. Barry too. Okay. All right. Please let me quickly explain this because we're out of time. So it takes in that weekly data, and what it does is there are parameters here. All these parameters, if they are all false, the only results you would have, okay, you will not even have any results, right? Because this is just a visualization function, right? But yeah, if you set all these ones to false, let's say I take all these ones out, it's just going to plot only the, which is just the the visualization for just that exchange, right? Okay, I think if I take this out, it's just going to work. Yeah, not as much. So yeah, that function has a lot of parameters. Right now, if you don't pass in any of the parameters, if you don't set them to true, it's just going to visualize this entire data set to you. It's going to visualize the open, close, and high for this exchange that we are working with. And this is what it looked like. So this is a range slicer which was added to our plots on Plotly. With the where is I'm looking for where I can't find it. Okay, I'll look at that later. But this is it. You can actually zoom in using the range slider. Then again, it's too small. So let me bring back the other parameters. So the other parameters, if they are set to true, it goes ahead to plot other kinds of visualization. So the closing set to true will plot only the closing price. This is what only the closing price is. You are seeing this graph because there are missing values. And this is obviously going to be coming from the open or high up or low. But when you plot only the closing price, because the missing values was handled, you will not see any gap. You will not see any gap. Okay. But then again, this is what the chart looks like. This is the trend. Now, this is a density plot, which came when we set AD equal to 3. autocorrelation to 0 to the autocorrelation plot. They didn't say the plot and it looked bimodal, right? It looked bimodal. If not, it doesn't have that uniform shape. It doesn't have that uniform shape. We're running out of time. Okay, so I'll just give us the next few minutes to ask question, and then I think in our next class I'll continue from here. I will not actually go on to be explaining the other things. Probably I'll just rush through it. But in our next class, I'll continue from here so that I can explain other ones better. Then we go into how to make the data stationary. We look at the rolling average mean and the rolling in and standard deviation. We look at our Dickey-Fuller test to know if the data is stationary, how to interpret it. Then we look at the seasonality, the composition of our chart. Then we go into making the data stationary and then we go into model. So we have a lot to learn in the next 2 days. But yeah, it's going to be an interesting one. And I just hope you are following. So yeah, does anyone have any question for me? Let's take the next 2 minutes. Any question? The whole essence of this project specifically is just to, I mean, it's in line with the stage called which time series, and also how to show you, it's also to show you how you can make your code more clean and more professional, right? And yes, you've been hearing of import this, import that. You can also create your own module that does something for you. Because right now, as it stands, this stuff is very dynamic. Meaning, if I want to maybe predict for another exchange, it's as easy as probably just going back to where you selected the currency. But this is where everything begins. This is where everything begins. If I want to maybe work with USD or any other fiat currency, I just have to come here and that's again. I mean, this is still manual because if you still want to automate it in a way that you don't have to be scrolling up and down, you can still turn it again to another big function that takes in all the things. But I mean, that is time for you. So that's another thing you can one can do to improve on this code to make it automated. But yeah, this is how you can actually make the work clean, make these functions, learning functions. Most of us don't know how to use it. But yeah, this is how you can make use of it. Maintain parameters in functions, how especially pandas, you will say CSV, uh, delimiter is equal to this. That delimiter is for someone that created it. So that's also how you can add your own parameters and set it to true or false, and it works for you fine. So this should not just be just about time series, but also gives you an insight into how you can arrange your code base and make your work clean. So yeah, we'll stop here. Our time is up. So once we come in the next class, we'll start from here, and I'll just quickly explain these charts and how you can interpret it. Then we go into the other ones later. All right, I'm not seeing any question. Nobody's raising his hand up, so I'll assume that we all understood what I've been explaining, and we are looking forward to the next class. So yeah, it's
Thank you so much.
a bye bye for me. Yeah, I'll see you all in the next class. Bye everyone.
Bye.
Okay. Well,